This is the second part of our video audio lecture where we look at problems from chapter 2. So we are looking at problems from chapter 2. These are the important equations that you need to be able to solve all the problems in this chapter. We talked about average speed. We already talked about acceleration. We already talked about the distance of a falling object, and we already talked about centripetal acceleration in the audio lecture 1. So let's look at specific problems that relate to this. So here is the problem. This problem talks of a track meet, and first and foremost, we need to know what we are given. So we can say given, and you'll find it extremely helpful if you always do this. We are given the distance in this case. So the distance is equal to 100 meters. Keep the units, and I'll try to explain that as we go on. We are also given the time, I'll represent it by the symbol T, and this is 12 seconds. So after you have written everything you are given, you need to try to determine what do they want? What are they asking? So in this case, we know that they are asking for the average speed. Now, if you recall, average speed, or speed in general, is total distance divided by total time. So this is total distance divided by total time. And then you can put in your numbers from what you wrote down in the given section. So here we go. You say this is 100 meters divided by 12 seconds. And all you need to do is to punch this on your calculator. And if you do it the way I did, you end up with 8.3 meters per second. So our answer is 8.3 meters per second. Let me emphasize this again. It's important to always do this part for any problem. Write down the information that you are given, and that will help you in solving the problem. Let's look at our next example. This example sounds that it talks about a lot, but it's really very simple. He talks about the distance again. Note that the distance here is in kilometers. So what I want you to do is, when you say given, I want you to change that to meters. So we want to be using meters for all the lengths. Meter and feet, remember, is the standard. So we'll say given the distance, and the distance that is given here is given as 7.86 times 10 to the power 7 kilometer. But remember, a kilo is not a unit. A kilo stands for 10 to the power 3. So I can change this and say this is 7.86 times 10 to the power 7 times 10 to the power 3 meters. And some math rules say that if the base is the same, I can always add the exponents. So I can add 7 and 3, and this becomes 7.86 times 10 to the power 10 meters. The other thing that we are given is speed. So here it is. Speed, we are told, is 3 times 10 to the power 8 meters per second. And what are we looking for? We are looking for time. Again, I'll write time as t. So what relation relates these three? Oh, well, we know it. Its speed is equal to distance over time. So this is speed is equal to distance divided by time. But I'm looking for time, not speed. So I can rearrange this. So I'll multiply throughout by time. And what I will have will be time times speed is equal to distance. So all I did is I cross multiply. Now to get time on its own, now I divide throughout by speed, and what I'll get is that the time, which is what I'm looking for, is distance divided by speed. Now at this stage I can put in the values that I have. I know the distance from the given. It was 7.86 times 10 to the power 10 meters divided by, it's important if I have a wrong number like that to put parentheses, 3 times 10 to the power 8 meters per second. So if I punch this correctly in my calculator, don't forget the parentheses, I should end up with an answer of 262 seconds. And so that's our answer. So the time we are looking for is 262 seconds. Let's look at the next example. The next example says a race car is traveling northward. Note what it says again, on a straight level track at a constant speed. So let's write that. So we'll say given. So what are we given? So for part A, I'll change my colors. For part A, I'm given again the distance. Kilometers is a measure of distance or displacement. So this is 0.750 kilometers. Remember what we said in our last example? I can't use this. I need to replace kilometer to a number. So this is 0.750. Kilo is times 10 to the power 3 meters, which ends up to be 750 meters. Make sure if you have measurement of length, it's always expressed in meters. And then we are given time. And the time for part A of that journey is 20 seconds. Oh, we are ready to solve for part A. So here is part A. Part A, again, what we have is average velocity. This is how you show average velocity with a bar on top, is equal to displacement. Since it's in a straight line, that's the same as distance, divided by time. And so in this case, it will end up to be 750 meters divided by 20 seconds. And so 750 divided by 20, I think ends up to be 37.5 meters per second. So our answer is 37.5 meters per second. So there it is. How about part B? Well, if you look at part B, note what he says. So what he says is, he starts off, I'm going to sketch this. So he starts off at this point, goes 750 meters to point B, taking 20 seconds, and then he comes back the 750 meters, taking 25 seconds. Now, if you recall what we said about displacement, displacement looks at only two things. What is the straight line distance between the starting position and the ending position? Note, this is our starting position, and the same position is our ending position. So there is no difference between our starting position and our ending position. Therefore, we know that the displacement in this case is equal to 0. Therefore, the average velocity will equal to the displacement divided by the time. And what we'll end up with is 0. The time was 20 plus 25 or 45 seconds. But 0 divided by any number is equal to 0. And so the answer to part B is 0 meters per second. I hope you are finding this very easy, and I hope the explanation will help you as you go forward. Let's look at our next example. The next example, we are looking at a sprinter that starts from rest. Rest means the speed when he starts is 0. Rest stands for 0. And he runs to a speed of 12 meters per second, and it takes him 6 seconds. So let's do what we did before. We'll say given. What are we given? Well, we are given the initial velocity. Your book uses v subscript 0, I usually I. And this we are told is rest 0 meters per second. So we'll say rest. And he goes to a final speed of 12 meters per second, and the time it takes is equal to 6 seconds, and we are looking for the acceleration. So the question is, how do all these related? We know the definition of acceleration. Acceleration, we said, was change in velocity, so v final minus v initial divided by time. Now I can put in the values. My final was 12. My initial was 0, and I'll take all this divided by time, which was 6 seconds. Remember, this is in meters per second. And so my answer will end up to be 2 meters per second squared. So far, so good. Well, let's look at a few more. Here is our next one. Now, this one we are told he is moving in a circular track and is at a constant speed. Immediately I know that this has to do with centripetal acceleration. So let's write down what we are given. So what are we given? Oh, look at that. Instead of being given the radius, I'm given the diameter. I'm told that the diameter is 1 kilometer. So far you have gotten news. We can't use it because I need to change that k to times 10 to the power 3 meters. So it's 1,000 meters. But this is the diameter. Remember, in the expression for centripetal acceleration, we need the radius. It turns out that radius is simply equal to 1/2 of that diameter. So I'm going to do it right away. It's diameter divided by 2, and it ends up to be 500 meters. Okay, what else are we given? We are given the speed, and here we are told the speed, I'll use v, is 90 kilometers per hour. Now, I can't use this. What I need to change it to is to meters per second. Remember what we did in chapter 1? You need to look for a conversion factor. Now, if you look very carefully at the back of your book, you have this conversion factor. It will say 1 kilometer per hour is equal to 0.278 meters per second. I hope you can find it. It's at the back of your book. And so now, all I need to do is arrange this as a fraction to convert it. So here I go. So I'll say V is equal to 90 kilometers per hour. This is the same as 90 kilometers per hour times, and then I will have my conversion factor. Remember, my conversion factor, I want to arrange this as a fraction, so what I'll have is I'll put 0.278 meters per second on top, and I have 1 kilometer per hour at the bottom, and the reason is so that I can do this. The kilometer per hour cancels out. And if you work this out, it turns out to be 25.02 meters per second. So now I know the radius, which is this value. I know the speed, which is this value. I'm looking for centripetal acceleration. So I know my acceleration is given by the centripetal acceleration is the square of the velocity divided by the radius. And so I'll put in those values. I'll have 25.02 meters per second. Don't forget to square it, squared, divided by the radius, which was 500 meters. And if you do this, you end up with an answer that looks like 1.25 meters per second squared. So far, so good. Okay, 2 more examples. The next example is this. So what we have is projectile motion. How do I know it's projectile motion? Because when you hit something at an angle, it will go up in the air and then it will come back. But we know it will land somewhere there. So here it is. So this gopher, he shoots it at an angle and it lands somewhere there. Now this angle is given as 42 degrees. And this distance is 100 yards. And so the question is, what other angle can he fire this ball so that it lands at the same position? Remember what we said? Complementary angles will always give the same range. Complementary angles always give the same range. Range there is that horizontal distance. So what's a complementary angle? Are two angles that will add up to 90 degrees. So I know this, that if I take 42 plus some angle, I should get 90 degrees. What angle can I add to 42 to get 90 degrees? Well, if I do the math, the angle is 90 minus 42, and it ends up to be 48 degrees. And that's it. Okay, last question. The last question we have is our student, he drops the object from the window on the top floor. How far in meters did the object drop in 3 seconds? Here is what Galileo Galilei said. He says that the distance it's dropped is equal to 1/2 gt squared. So let's start with what is given. So given is, I'm given is time, and this is equal to 3.0 seconds. It doesn't look like much, but it's because I know what g is. G is always 9.8 meters per second squared. So I can find my d. So according to this, my d will be 1/2 of g and t squared. Put in the values, I'll have 1/2 of 9.8, and my t there is 3, but don't forget to square it. And that will be my value in meters. It ends up to be 44.1 meters. And that's it for chapter 2. I hope you enjoy it.